Assalamualaikum warahmatullahi wabarakatuh. So today we would like to do the project sustainable product for ECS246. Okay, but firstly I would like to introduce our group members. First we have NORFAEZ IMRAN bin NORAIMY. Second me, Muhammad AFWAN bin AZHAR. Third, Muhammad Amir Hazim bin Muhammad HASSAN. And lastly we have Muhammad NIZAMUDDin bin Muhammad NORDIN. Project, we have two researchers. Okay, first palm oil full ash (POFA), and second we have sugarcane bagasse ash (CBA). For each research, we pointed four things: first introduction, second materials, third methodology, and lastly result. For introduction for POFA, okay, concrete is a man-made material that is commonly utilized in the construction industry as a building material. Okay, the utilization of waste material as a concrete ingredient is becoming more widespread these days. Okay, the discovery of the alternate conventional building material that is cheaper and accessible becomes a highly critical issue. POFA is one of the such material. Okay, POFA is a type of agro waste produced by the palm oil industry. The POFA is produced from the burning of oil palm fruit residues. It has become a major problem to the palm oil power plant because the waste is not reused and recycled in any works. So that POFA can be used in cement replacement due to the chemical composition contains a large amount of silica. Now, for the materials that we use are ordinary Portland cement, coarse aggregate such as gravel, fine aggregate such as sands, okay, super plasticizer master ganium SKY8233. We use to affect the fresh concrete properties by increasing the workability in concrete, and then palm oil full ash, and lastly we have water. Yeah. Now we move for the methodology.
Methodology and result for palm oil fuel ash. In our research, methodology is divided into three sectors, which is physical and chemical properties, mixed proportioning, and test specimen. We will go to the physical and chemical properties first. So, physical and chemical properties of various material used in the experiment were shown in the table below. For the chemical composition of palm oil fuel ash, first is silica, then iron, potassium, sodium, magnesium, calcium, aluminium, and sulfur. So there are 8 chemical composition in palm oil fuel ash. So for the percentage in palm oil fuel ash is 20.1%, 8.106%, 3.784%, 0.07%, 1.8%, 4.058%, 2.376%, and 0.16% respectively. Okay, so for the properties of cement, property there are specific gravity, which is the test result is 3.15, initial setting time is 19 minutes, and for the consistency is 31%, and for the compressive strength is 53 Newton per millimeter square, and for the fineness is 2%. And for the properties of aggregate, there are two types of aggregate, fine and coarse. For the fine aggregate, specific gravity is 2.66 and fineness modulus is 2.5. For coarse aggregate, specific gravity is 2.7, and for the water absorption is 1%. Okay, I think that's all for the data of physical and chemical properties. Now we are going to go to the mixed proportioning. So for mixed proportioning, the target compressive strength was 14 megapascal and water to binder ratio was 0.3. 5 samples were prepared, in which one is the control mix of 0% palm oil fuel ash. So cement is replaced by 5%, 10%, 15%, 20% in rest of the samples. So cement in kilogram is 450 and water in kilogram is 135, and for fine aggregate is 783.45 kilogram, and for coarse aggregate is 1146.23 kilogram, and then the super plasticizer is 0.9 kilogram. And this is the mix design for 1 meter cube of concrete. And then we go to the test specimen. So the test specimen is compressive tests were done on cubes of 100 millimeter size for curing periods of 7 days and 28 days. And the flexural compressive strength of concrete was determined by beam of dimension 100 by 100 by 500 millimeter and of size for curing periods of 28 days and 56 days. The split tensile strength is evaluated by cylinders of 100 mm diameter and 300 mm length for curing periods of 7 days and 28 days. So 3 specimens were cast for each testing case. We have a 5 sample number, and for the mix ID we tag as CP0, CP5, CP10, CP15 and CP20. This is as they are for the percentage we have divided as I mentioned in the methodology before. And for the compressive strengths in Newton per millimeter square, for 7 days the result we've got is 33.83, 33.89, 36.02, 37.1, 34.67, 31.68 respectively. And for the 28 days result, we've got in the research is 40.23, 41.61, 43.08, 40.82 and 39.55 respectively. And then the graph shown in the slide is about compressive strength in Newton per millimeter square times versus percentage of the palm oil fuel ash. Strength test result in our research, we've got 20x days and 56 days, and for 28 days there are 3.87, 3.89, 4.07, 3.94 and 3.85 Newton per millimeter square respectively. And for the 56 days, 4.09, 4.13, 4.36, 4.21 and 4.1 respectively. And as the graph as shown in the slide, there are compressive strengths versus percentage of palm oil fuel ash. Split tensile strength result, the data we accumulated is 7 days and 28 days as we mentioned in the methodology before, which is the result we've got is 2.56, 2.56 or so, 2.81, 2.69, 2.55 Newton per millimeter square for 7 days respectively. And for the 28 days, 3.11, 3.13, 3.27, 3.2 and 3.0x respectively. Okay, for the graph as shown in slide, the compressive strength versus percentage of palm oil fuel ash, that's all for palm oil fuel ash test result.
Second, our research article, which is sugarcane bagasse ash. For the introduction, in tropical and subtropical areas, sugarcane is the primary food crop. It is the most important resource in the sugar industry. Sugarcane bagasse ash, which is SCBA, is made by burning sugarcane bagasse under the control setting. The use of waste material in concrete is extremely important for reducing impact on the environment. Sugarcane bagasse ash is one of the industry waste products. Using sustainable in concrete is one of the most effective strategies to reduce the environment impact. For the material that we use in sugarcane bagasse ash cement is first is the ordinary Portland cement, second is coarse aggregate, and third is fine aggregate, and then number 4 is sugarcane bagasse ash, and the last one is the water.
For the methodology, first we need to prepare our sample to be used for the concrete mix. In the present work, proportions for concrete mix design of M20 were carried out. For making the mixes containing sugarcane bagasse ash, the amount of powder to be used is calculated. The bagasse ash itself was burned approximately 72 hours in air in an uncontrolled burning process with a temperature of 706,000 degrees Celsius. The ash then collected and being sieved through BS cylinder size of 75 mm. It was then measured by volume to replace the cement at 5, 10, 15 and 20%, and here are the data of the concrete mix proportioning. About the aggregate used, crushed granite rock with maximum size of 20 mm was used as coarse aggregate, and the natural sand from Swarnamuki River in Sri Kalahatchi was used as fine aggregate. So this research continued with the slump contest and compressive strength. Here we have the result of the slump test as the data guide. The replacement of 10% of bagasse ash with cement in mix to have a higher slump value. This shows that mix has a higher workability. The result shows that the maximum compressive strength for 7 and 28 days curing period achieved are 7.93 and 30.57 respectively with 10% replacement of cement by bagasse ash. The results show that the SCBA in blended concrete had significantly higher compressive strength compared to the controlled concrete. It reveals that the cement could be advantageously replaced with SCBA up to maximum limit of 10%. For the discussion, we discovered that each of the three sustainable resources, palm oil fuel ash, POFA, sugarcane bagasse ash, SCBA, has the ideal replacement percentage to produce a good quality concrete after multiple tests. For POFA, cement was substituted by 5, 10, 15 and 20% with POFA in the rest of the sample for all of the tests that were conducted. However, 10% replacement is recommended percentage. For the entire test, it has the maximum compressive strength, flexural strength and tensile strength. Two tests were then conducted to investigate the reaction of sugarcane to concrete when it was used to replace a small percentage of the cement. Both tests were carried out with M15 and M20 concrete grades. Increasing the percentage of sugarcane replacement in cement can increase the workability of fresh concrete, according to the slump test result. However, only 5% replacement rate is available. All of this was made possible by our lecturer knowledge as well as the assistance and discussion provided by colleagues. We have the ability to appropriately collect and analyze data. In the nutshell, we are able to finish our research on the use of sustainable material as concrete replacement. The strength qualities of concrete change when some of the cement is replaced with palm fuel oil ash. Increase in the replacement of sustainable materials beyond a certain point result in a loss of strength. Based on analysis of numerous tests, the percentage of replacement that produced a better outcome was 10% replacement palm oil fuel ash POFA, and then 5% replacement cement with sugarcane bagasse ash SCBA. It is not necessarily to use a super plasticizer. The research was a little confusing because it didn't evaluate the application of SCBA in the concrete for a variety of quality such as modulus of elasticity, flexural test, split tensile test, and drying shrinkage. The research study will help in the production of future sustainable product by reducing the rate of waste and increasing the use of sustainable products.